Hey guys, welcome to the notes for substitution. We are in Unit 5 and it is the second day to learn how to solve a system of equations. Just a warning that these notes kind of copied weird, so like this should be essential question, so EQ. Like some letters are kind of cut off and it looks kind of silly, but you get the idea. I'm sure you could like make out what it's trying to say. Anyways, so we're going to learn how to do use substitution. So our essential question is, how is the substitution method used to solve a system of equations? So the first method that we learn how to solve a system with is by graphing. And sometimes graphing isn't really that convenient, especially if we are not provided a graph and we have to hand draw a graph, so it's super inconvenient. Substitution is the second way we can use to solve a system of equations. And sometimes one way is easier than the other way. So we're going to learn three different methods. So we've learned how to solve by graphing, right? When we graph, they either intersect at one point, they don't intersect at all and they're parallel, or they intersect an infinite amount of points if they're the same line. With substitution, we'll get the same types of answers. We're just going to see it more algebraically and not really graphing. Okay, so there are some steps for substitution, but you're going to get so good at substitution, you're not going to have to look back at the steps. So when you think about substitution or like a substitute, what do you think of? You think of something to replace, right? You're replacing something. So if I'm absent, there's a substitute that comes in to replace me for the day. Or if you have a substitute for a food item, you're replacing the original food item with a substitute. So substitution is that same idea. You're going to be replacing or substituting something in. All right, so the first step is that you're going to solve one of your equations for either x or y. It does not matter. It does not matter which one you do. So you can solve it for either x or y. And remember, we're talking about a system of equations, so there's going to be more than one equation. And so in Algebra 1, we deal with two equations. So we have two equations, and you can solve either one of them for x or y. And these steps might not make a lot of sense because you're not really doing them, but once we do them, you'll get the hang of it. The second step is that you want to substitute the resulting expression in parentheses into the other equation. Again, this is hard to visualize, but when you're substituting something in, anytime you plug something in, you always use parentheses. You use parentheses so that you make sure you do not make a mistake. Okay, this next step is very important. You should only have one variable now, and it will make more sense later, but once you substitute and put that in parentheses, your equation should only contain one variable, either all x's or all y's. All right, number 3. Once you have a solution, you're going to plug it into the other original equation. Keyword here is original and other. You want to plug it into the other one. You don't want to plug it into the one that you just converted or simplified, right? You're going to plug it into the other one, and I'll show you what I mean by that. And I circle original because it's the original equation. It's whatever the equation you started off with. And then the last thing is you're going to write the solution as an ordered pair, which looks like x comma y, right? You're going to write it as a point. Just like with graphing, if my lines crossed at one point, the solution was at that specific point. And I am going to hop over to Desmos after I finish the first problem just to show you that you could also solve it by graphing. So every single problem that we're doing here, we could actually graph them and we would get the same answers. Okay, so on number 1, we have 2x plus y equals negative 10 and x plus 3y equals 10. I also have room there to check, and so we'll do that at the end of the first problem, but I'm only going to have you do it for the first problem because it is an extra step. It's not necessary, but it's one of those tools that I want to show you so you can always make sure to see if you're correct or not. Okay, so I have two equations, right? I have a system of equations. I have two equations. If I scroll back to the top, the first thing says to solve one of those equations for either x or for y. So I need to pick one of my equations and I need to get one of the variables by itself. So I can either pick the first one or I can pick the second one. It does not matter. Now, I'm just going to pick the first one. Why not? I'm going to pick the first one and I want to look at it. You can solve for either x or for either y. Okay? So what is already by itself? And what's the easiest thing for me to get by itself? The easiest thing for me to get by itself is that y, because there's nothing attached to it. For example, if you were to pick the other equation, let's say you picked the one over here. And you know what? For purposes of this problem, let's go ahead and do that. Let's pick the other one. For this one, we have x plus 3y equals 10. Well, what's the easiest thing for me to get by itself? The x. The x is already by itself. So I'm going to go ahead and I'm going to subtract 3y on both sides. And you're like, why? We always get y by itself. It doesn't matter, right? You just need to either get x or you get y by itself. X equals 10 minus 3y. Okay? So the second step says to substitute whatever we just got, the resulting expression, in parentheses into the other equation. So let's put that into play. I just got something by itself, right? I got x by itself over here. I'm going to take this over here and I'm going to substitute it in to the other equation. It says that x equals 10 minus 3y. Do I have an x in the other equation? Yes. I'm going to plug this in for x here. And when I plug that in, I need to use parentheses. So I'm going to have 2 times 10 minus 3y because x equals 3y, or x equals 10 minus 3y. And then I have plus y equals negative 10. What's the only thing I did here? I substituted my x for 10 minus 3y. And why did I do that? Because x equals 10 minus 3y. Okay, now once we're here, what does the next step say? It says you should only have one variable now. So let's double check. In this equation, I only have one variable. I only have y's, right? I have y by itself. So it says the next thing is that once you have your solution, plug it into the original equation. So I need to solve for y here. So we need to get y by itself. The first thing I'm going to do is I'm going to distribute. 2 times 10 is going to be 20. 2 times negative 3y is negative 6y. Then I have plus y equals negative 10. And then I always want to look for like terms. And in this case, I do have like terms. I have negative 6y plus y. So that's going to be 20 minus 5y equals negative 10. So I still want to get y by itself, so the next step I'm going to do is subtract 20 on both sides. And I get negative 30. Because negative 10 minus 20 is negative 30. And I still need to get y by itself, so I'm going to divide both sides by negative 5. Negative 5 divided by negative 5 is 1. And then negative 30 divided by negative 6, or negative 5 is positive 6. And you're like, oh, that's my answer. I'm done. But you're not done, right? If I have two lines and they cross each other, they cross at a point, which means x comma y. Right now, I only have the y value. So it says, once you have a solution, plug it into the other original equation. So I just plugged it into this one. So I can't plug it into that one. I got to plug it into the other one. So this equation right here. And really, it doesn't really matter which equation, but I prefer to just pick the other one so that it is a little bit more consistent, so you don't want to use the same equation again. But you can. You can. I would just prefer that you don't so that you don't make a mistake on accident. So we have x plus 3y equals 10. Where did I get that? It was this equation from earlier. Okay? I'm going to take what I just had here, right? I got y equals 6, and then I'm going to substitute it in for my y value, because I have a y value here. So then I have x plus 3, and anytime you substitute, you always use parentheses. So y is going to be now a 6 in parentheses equals 10, and then now you simplify. So this is going to be x plus 18 equals 10, and then I have minus 18 on both sides. And I have x equals negative 8. Okay, so I now have two values. I have an x value, and then I have a y value. So what is my solution to this system of equations? My solution is going to be a point, right? The next step says to write the solution as an ordered pair. Then that would be negative 8, comma 6. Just like when we graphed, we would have a solution. That means they intersect one time. Okay? Now, how would I check this mathematically? So the way you can check this is you pick one of your equations. It doesn't matter which equation you pick. I'm going to go ahead and pick 2x plus y equals negative 10. But again, it doesn't really matter. And then you're going to plug that point in for those x and y values. So you have 2 times whatever your x value was, which was negative 8, plus whatever your y value was, which is going to be 6, equals negative 10. So I'm checking here. I'm checking to see if this works. Then I get 2 times negative 8, which gives me negative 16, plus 6 equals negative 10. Negative 16 plus 6 is negative 10. Does negative 10 equal negative 10? Yep. So you can actually check to see if your solution is correct. So you should get the thing that equals. So substitution, again, you're just substituting a bunch of different things, lots of arrows going on, lots of circles going on. I do that to help you visually, but you don't have to do that. Now I'm going to hop over to Desmos and show you something. So you should be taking notes, and if you're not, you're wrong. But I'm going to go ahead and type both of these equations into Desmos. So if I were to graph these, I would have 2x plus y equals negative 10, and it already graphed it for me, so I didn't have to do much of the graphing myself. And then I have x plus 3y. Oh my gosh. X plus 3y equals 10. Okay, so it graphed 2 equations for me. If I click on the part where they intersect, it pops up a gray point. And if I click on that gray point again, it gives me the solution, which is negative 8, 6. Is that what I got when I did substitution? Yes. So again, you can solve it many different ways. Substitution is the more mathematical approach to it. All right, so let's go ahead and do number 2. And we're not going to check on this one, but we are going to solve by substitution. So you always want to look at both of your equations and see, is there one that's easier to get the variable by itself? So here I have 2 equations. I have 2y minus 7x equals negative 7, and I have x equals 1 minus 2y. If you haven't noticed already, notice how the second equation already has x by itself. So it already did some of the work for me. It got x by itself. Once I have a variable by itself, I take whatever it equals and I plug it into the other equation. So because I have x equals 1 minus 2y, I'm going to plug that into the other equation, and I'm going to plug it in for x. Why for x? Because x equals 1 minus 2y. Sorry. Okay, so then I have 2y minus 7, and anytime I plug in, I always use parentheses. So I have 1 minus 2y equals negative 7. And again, this just takes a lot of practice. With anything in math, you always have to practice, and it just takes a lot of practice. Okay? And then next step here, you would distribute. So you would do negative 7 times 1, which is negative 7, right? So 2y is already on the outside. You want to distribute the 7 first. Negative 7 times negative 2y, that's going to give me positive 14y equals negative 7. And then you always want to look for like terms because, again, you only have one variable, and you want to combine that one variable into just one term. So you have 2y plus 14y, which is going to give me 16y minus 7 equals negative 7. Okay? And then I still want y by itself, so I'm going to add 7 to both sides. 16y equals, well, negative 7 plus 7 is 0, so I just have 16y equals 0. Okay? And now I want y by itself, so I'm going to divide both sides by 16. Okay? Sorry, I keep saying k. Y equals 0 divided by 16. If you do not know what the answer is, I suggest that you always type it in the calculator to double check. But because 0 is in the numerator, I know that I can divide anything, any number, and have 0 on top. So I can do 0 divided by any single number, and I'll get 0. So what I like to do once I get a variable by itself, I circle it because it's not my final answer. I always want to box my final answer, so that y equals 0 is not my final answer because I want a solution point. Right now I only have half of that point. Okay, now once you've already found one of your values, you plug it into the other original equation, where our other original equation was x equals 1 minus 2y. So x equals 1 minus 2y, and I'm going to take y equals 0, and I'm going to plug it in for y over here, because why do I plug it in for y? Well, y equals 0, so I plug it in for the y value. So then I have x equals 1 minus 2 times, Notability does that sometimes. Times 0, because my y value is 0. And anytime I plug in, I always put parentheses. I'm trying to save you from making a mistake, so you always use parentheses. And you have x equals 1, and then negative 2 times 0 is just 0, so minus 0. So I have x equals 1. So this is the other part of my ordered pair. So what is my solution here? My solution is 1, 0. And just like the other problem, I could graph this in Desmos and it would intersect. I would click on that point that it intersects at, and then it would say 1, 0. All right, number 3. So we have two problems here. We have x plus y equals 16 and 2y equals 2 minus 2x. Now, you have to judge for yourself which one of these is easier to get the variable by itself. So just looking at these two equations, this one clearly looks easier to get a variable by itself. Why is that? Because there's a 2 attached to this y, and there's a negative 2 attached to that x. So that would be difficult. I would have to divide something, so I'm just not going to get that one by itself. Now you can if you'd like to, and you'd still get the same answer, but you always want to go the easier way. You always want to do less work. So I'm going to go ahead and get this one and get a variable by itself. I can either get x by itself, or I can get y by itself. And just for the sake of difference and being different, instead of getting y by itself, I'm going to try to get x by itself. So to get x by itself, I'm going to subtract y on both sides. So I have x equals 16 minus y. Now if you want to get y by itself, that's perfectly okay, and you'll get the same exact answer as long as you do everything else correct. So it does not matter what variable you decide to get by itself. Okay, but my variable is already by itself. It's all done. Like, I don't need to do any more extra work, right? Because x is already by itself. So I'm going to plug that in. I'm going to plug 16 minus y in for the x value in the other equation. Do you have to draw all these ridiculous arrows? No. I'm going to so that you can see what I'm doing, because obviously you're just looking at a screen. So x equals 16 minus y. So I'm going to plug this in for my x value. So I have, let's use purple. I have 2y equals 2 minus 2 times my x value, which is 16 minus y. Okay, I'm plugging it in for that. Sorry, I was zooming out to double check it with the other problem from earlier. Oops. Nope, stop it. Oh my gosh, my iPad is going crazy. Okay. So again, now you should only have one variable. If you have two variables in the steps that are different, you're in the wrong, but because all of my variables are y, I'm good. So let's go ahead and distribute. So I have negative 2 times 16. So let me go ahead and get all this written down. Negative 2 times 16 is negative 32. Negative 2 times negative y is going to be positive 2y. And then I always want to check for any like terms. And I do have some like terms. I have 2 minus 32. Oh, I'm not going to do green, actually, because I used green earlier. So 2 minus 32. So 2y equals, well, 2 minus 32 is going to be negative 30. And then I have plus 2y. So now I want to get y by itself because I want to solve for y. And since on the left side, the y is already kind of by itself, I'm going to move the one on the right over. So 2y minus 2y is 0. And then I have 2y minus 2y. Well, that also equals 0. So what do I have left on that left side? I have 0, right? 0 equals negative 30. Does 0 equal negative 30? No. So what type of solution do I have here? I have no solution. If I have two equations and there's no solution, it means they don't intersect, which means the lines are parallel. So if I go to Desmos and I type in both of these equations, you'll notice I have x plus y equals 16. And these are, again, the equations that you have in your paper, because you should be taking notes. And then 2 minus 2x. And the reason why I stress taking notes is because you're not going to retain anything, right? Like, you're going to watch a video, and then it's going to go in one ear and go out the other ear. So you need to be actively taking notes. But if I'm looking at number 3 and I type in those equations, they're parallel lines, which means they never intersect, which would make sense because it says no solution. All right, moving on to number 4. We have 4x minus 3y equals 15, and we have x plus y equals 9. So again, looking at this one, you always want to do the one that looks easiest to get the variable by itself so that you can do the substitution. So for me, I know that this one's going to be the easier one because those x and that x and that y are already by itself. And since the last problem we got x by itself, let's go ahead and get y by itself in this one. So we can subtract x on both sides. So we have y equals 9 minus x. Okay, well, since I got my y value by itself, now I have y equals 9 minus x. Where am I going to plug that 9, oh my gosh, like word vomit. Okay, where am I going to plug in 9 minus x? Well, I'm going to plug it in for the y value of the other equation. So I'm going to go ahead and I'm going to move this for the y value. So then I have 4x minus 3 times 9 minus x, make sure you use parentheses, equals 15. So all I did again was just substitute that in. Then you want to go ahead and get the variable by itself. In this case, we have only x's, so we're going to get x by itself. The first thing we're going to do is we're going to distribute negative 3 times 9, which is negative 27. Negative 3 times negative x is positive 3x, equals 15. And you always want to check for like terms, and I do have some. 4x plus 3x, that's going to give me 7x. And I know I'm switching colors a lot, but I'm trying to do it as visually pleasing as possible here. Okay, and then you're still trying to get x by itself, so you're going to add 27 to both sides. And that's going to be, what is that, 42? 15 plus 27 is 42. We're going to divide both sides by 7. X equals 6. Is this my answer? No, it is part of your answer, so I'm going to circle it. And I like to circle things that are just part of my answer and not actually my answer. All right. Now I'm going to pick one of my equations. It doesn't matter which one, but I like to pick the other one. So I'm going to pick x plus y equals 9. Okay. And I know that I need to plug something in. I need to plug x in, or plug 6 in for x. So I'm going to put a 6 here. So this is going to be 6 plus y equals 9. And that 6 can really just be by itself now because there's no multiplication going on. Subtract 6 from both sides to get the y by itself. And I get y equals 3, which is the other part of my answer. So what is my ordered pair, or what is my solution? My solution is, remember, it's always x comma y. So it's going to be 6 comma 3. And with this one, if I were to graph it on a graph, they would intersect at the point 6 comma 3. All right, we have one problem left, and that is number 5. X plus 2y equals 4, and 4y plus 2x equals 8. So again, you want to always look for the one where you can get the variable by itself the quickest, which is going to be the one on our left here, because x is already by itself over here. So I'm going to subtract 2y on both sides to get the x actually by itself. Okay. I just realized that this is going to be in the way, so let me move this. Does that work? I don't know. Is that weird that it's placed like in the middle of the problem? Oh, you know what? We'll just fix it later. Okay. So I'm going to plug in. I'm trying to find a different color so that it's not clashing with the previous problem. Blue. Okay. I have x equals 4 minus 2y. So I'm going to plug this in for the x value because it says x equals that. So I'll have 4y plus 2 times 4 minus 2y equals 8. All right, so you always want to plug it in with parentheses and make sure you plug it in for the right variable. The most common mistakes are that when we solve for stuff, you either plug it back into the same equation or you just are plugging it into the wrong variable. Okay, so we have, I don't know why I changed colors. We have 4y, and then we do 2 times 4, which is positive 8, and then 2 times negative 2y, which is, negative 4y, equals 8. And then you always look for like terms, so you have 4y minus 4y. Well, 4 minus 4 cancels, and it becomes 0, right? So these actually cancel each other out. So what do I have left? I have 8 equals 8. Is this always true? Yeah, 8 does equal 8. So if I have a number that equals itself, this is going to indicate to me that I have infinitely many solutions. What does that mean? If I graph this in Desmos or I graph this by my hand, I'm going to have the same exact line. They have the same exact slope and the same exact y-intercept. So here you would have an infinite amount of solutions because the lines overlap each other and cross each other an infinite amount of times. That is it for the notes for substitution. So again, you're just trying to get a variable by itself. You plug that variable into the other equation, you solve that equation, you plug that new variable back into the old equation, and then you solve for the other variable. So you solve for one variable at a time, and then those give you your individual parts for your point in the very end. If you have any questions, please let me know. I will be here for tutorials.